the story of Makerspace.
The frame of our drone is head-shaped and is made using carbon fiber, which is light and strong.
We supply the power to drone by a 2200 mAh LiPo battery, which has a high current rating.
The drone has 4 BLDC motors, propellers and ESCs. The ESCs provide 3-phase supply to the motors which rotate the propellers. The propellers push the air down, causing the drone to lift.
Alternate motors rotate in the same direction so as to prevent the net reaction torque on our drone.
We control the drone movement by changing the relative speed of each propeller.
The MBO 6050 has an accelerometer and a gyro which measures the accelerations and angular velocities along 3 orthogonal axes. The drone has a Wi-Fi unit, Node MCU, for communicating with the transmitter. It also has an Arduino Nano which provides onboard computation and sends PWM signals to the ESCs.
We are using Remote XY, which is a graphical user interface which helps us to control the actions of the drone, which includes throttle, yaw, roll and pitch.
We were very thrilled at the idea of making our own drone. We couldn't wait for the Project Lab sessions to start. After learning of so much of theory, we were really excited to put our ideas into actions. But we did not know what difficulties were in store for us.
The first 2 labs were very smooth, and by starting with the drone assembly, we built the framework and attached component to it.
In the next session, we learned about the circuits, figured out the connections and soldered the electrical components onto the drone with the help of the TA. This too was pretty straightforward.
The next lab had an unexpected surprise for us. We discovered that in hardware projects, many unexpected errors pop up.
While the other groups played with their joysticks, our group struggled to upload the code on the Node MCU. We tried using different laptops, cables, but nothing seemed to work. We all started to panic.
After thorough testing, we realized that our Node MCU was not getting any power. We were devastated. The fact that the other groups had completed most of the steps did not help us.
In the subsequent lab, before resoldering the Wi-Fi module onto the drone, we decided to check the Arduino as well. Surprise, surprise, that too was busted. Can you believe our luck? We tried to run multiple sample codes on it and none of them functioned properly. With errors piling up and us being more than 2 laps behind, with 2 damaged boards already, it seemed hopeless.
And then we struggled on. But the TAs, RAs and the profs really motivated us. They provided us with the additional boards and even helped us in resoldering. They even allowed us to come after the classes to get back on our track.
We had been given a glimmer of hope and we were determined to make it count. We rushed from lab to classes and from classes to lab. It was all really hectic and tiring, but we were ready to do whatever it took to make our drone fly. Finally, with the help of the TAs and the RAs, we managed to catch up with the others.
In the next lab, would you believe our Arduino malfunctioned too? But this time we were calm and collected. We methodically troubleshooted the issue and decided to resolder a new Arduino.
Sailed through the rest of the tasks without any difficulty. The code upload, testing and calibration went through like a breeze. After the motors ran, we were overjoyed and felt like the goal was near.
Throughout all the major issues, we had been doing mechanical problems, solving minor problems, fixing things and so on. And all the problems sorted, we were finally filled with curious energy to fly our drone. first drone picture for village.